So I wanted to lock the room so we could have an immersive talk and treat it like an escape room so we could find the clues and get out. But the building managers told me I'm not allowed to lock the room because it's apparently a fire and safety hazard. Um, but I've got a backup plan. So I've got some rope, duct tape, and some fluffy handcuffs. I just need a volunteer now. I don't want to kink shame anyone, but some of those hands went up really quickly. We're not here to talk about your kinks, though. We're here to talk about my kinks. My kink at the moment is escape rooms. I am obsessed with escape rooms. I do as many escape rooms as I possibly can. Every time I travel somewhere, I try and find a new escape room I can do. In fact, there's probably only about 2 or 3 escape rooms that I haven't done in Johannesburg yet. And I have to ration them out for special occasions or when I'm feeling particularly down and I need a good pick-me-up. In fact, I've done an escape room. It's not updating the background there. Okay, well, once we eventually get there, I've done an escape room on 6 out of the 7 continents. The only one that I haven't done one on is Antarctica, which presents a problem because there are no escape rooms on Antarctica. I also have a completionist attitude, so I really want to be able to do an escape room in Antarctica. So I've come with 2 plans. The first is to completely destroy the Antarctic. It's a little bit tight on my budget, but I am saving up for it. We'll get there one day, I'm sure. The second is that I'm going to completely change careers and become a research scientist because there are research bases on the Antarctic, which means that when I get there, I can get in a research building and wait for the storm. When I'm there and the storm's just about to arrive, I can find all of the access cards and control mechanisms and throw them outside, thereby triggering a forced escape room with my new colleagues. They're going to love it. So South Africa does have a research station in the Antarctic, but I wouldn't do it there, not for any patriotic reasons. I would instead do it at the Norwegian research station because that's the one there. It is known as the Troll Station, which sounds like the best place to act like an idiot. So that is where I would choose to do it. Now you might be sitting there asking yourself, well, why would this idiot go and create his own escape room? And that's a fantastic question, and I really should have asked myself that beforehand because it was a lot more work than I expected. But I decided I wanted to create one for these 2. These 2 are my daughters, and I absolutely adore them. They know that I love doing escape rooms, and they asked me the one day if they could go and do one with me. And unfortunately, in Johannesburg, there just aren't escape rooms that are at an appropriate level of difficulty for children to enjoy or to engage with. So I thought to myself, hey, self, I've got a good idea. Why don't we make an escape room for these 2 kids? And that started and spiraled into a whole 3-year project that ended up in a lot of fun, actually. But before you build an escape room, I wanted to identify what I wanted out of an escape room. So I started looking at the things that I enjoy about escape rooms. And one of the core things that I like is the themes, the decor of escape rooms. So this is terribly washed out in this projector, but this is very quintessential escape room decor. This is a gothic room. It's dark. Even if you didn't notice the padlocks all over the room, this is a quintessential escape room experience. Unfortunately, I don't live here. But if you do live in a place that looks like this, I would desperately love to meet and talk to you because you must be one of the most interesting people in the world. This room also has a bunch of decor on it, some weird pictures, like this one on the left-hand side, which you can't read here, but it says, "Hell hath no fury like a woman scorned." Great quote, love it. Have never met a single person that's got this hanging up in their house. So if you do have this in your house, again, please come and talk to me. I want to meet you. But the hell is spelled like H3LL, so it's very clearly a clue for one of these padlocks somewhere. So for me, one of the first things I wanted an immersive theme. I wanted something that would engage the people that were doing the escape room. The next thing I wanted lots of different rooms, lots of things for the players to open up and explore. Some of my favorite moments in escape rooms where you open up a room and you solve all the clues and you get to the end door and you open it and there's a whole new set of clues and puzzles for you to solve and you have to run through and discover new things. It's fantastic. Now, when I was doing this for my children, I thought, well, I don't know where I'm going to run this escape room, so I need to be able to have the option to have lots of different chests and padlocks and things. It needs to be adaptable to different environments. I also want the puzzles to be stimulating, to be engaging. And for that, I mean, I don't just want like pretty puzzles. Obviously, I want the puzzles to look nice, but I want puzzles that stimulate different senses. Maybe some puzzles that utilize a sense of smell or sound or touch. I want when the people see the puzzles, I want them to be intrigued by them, to want to interact with those puzzles. Most importantly, I want the escape room to be finishable. This is super zoomed in as well. So if the escape room is finishable, it's great. But I don't just want the escape room to be finishable within 20 minutes, because if it takes you 20 minutes to do the escape room, you haven't really engaged with the puzzles in any meaningful manner. For me, the best is when the escape room takes between 50 and 60 minutes to finish. In fact, I've got great memories of completing the last puzzle in many escape rooms, and you look up and you see the clock and it's 59 minutes and 30-something seconds, and you have to sprint to get to the front door before the time expires. I love that. With all of this in mind, what I wanted from my escape room was, is it showing there correctly? Yes, okay. I had a set of requirements. I wanted simple puzzles because I didn't want to explain to the children how to interact with each puzzle. Simple doesn't mean easy though. An example is if you push a button, that's simple and it's easy. But if you put the button behind laser tripwires, it's still simple, but it's a lot harder to do. So I wanted simple puzzles. I wanted the escape room to be finishable. Again, I wanted it ideally within the 50 to 60-minute time frame. I wanted different areas for the players to explore, lots of different opportunities for them to get new sets of puzzles that they can interact with. And I wanted everything to have a sense of wonder. That includes the theme, the types of puzzles, the way that the children interacted with it. I had some optional requirements as well. I wanted a lot of replayability, which means I needed to be able to reconfigure a lot of the puzzles, because I wasn't going to go through all of this effort, which I thought was only going to take 3 months to run it once. Of all of these requirements, the hardest by far was making it finishable within that 60-minute time frame. Because I don't know if anybody here has ever met a child or has been a child before, but children are smart sometimes. And then other times, I don't want to say they're not smart, but perhaps they're just smart in different ways that we realize. So how do you choose the difficulty of an escape room so that it's going to take between 50 and 60 minutes for a bunch of children, which depend on how much sugar they had in the past half hour, may be super geniuses or may be test candidates for parachutes? What I eventually settled on was I needed to be able to change the difficulty of the escape room on the fly. But I had to do this so the players didn't realize I was changing the difficulty, which means if they were taking really long at the beginning, I needed the puzzles later on to automatically become easier. Or if they were going through really quickly, I needed the puzzles later on to become a little bit more difficult. Which means all of the puzzles needed to have sort of an adaptive level of difficulty. Let's have a look at some of the puzzles that I made. We're only going to cover a few. There's plenty more. If you want to learn more about the other puzzles, you're welcome to come grab me afterwards. This is a balance puzzle where there's a digital spirit meter in there, and the players have to get it to be perfectly level for a second or two. Now, the way I can change the difficulty of this is I can change how close it must be to perfectly level. After that, I could also change how long it must be perfectly level. For instance, if they have to hold it there for 2 seconds, it's a lot harder than if they have to just blip it over. I can also change the number of targets it must point at. Because it's a digital spirit level, it doesn't always have to be perfectly level. I can have it start off level, then they have to point it to the door, then they have to point it to the window, and then the bookshelf. So you can change the number of things that it has to point at before it unlocks the next puzzle. You can also change how they manipulate the puzzle. So when my kids did it, they did it with string, but when I run it for older players, they maybe do it with pulleys or indirect mechanisms with levers. You can't change this on the fly, but you sort of, based on the estimated cleverness of your players, you can choose beforehand what it should be. Another fun puzzle for the kids is one I like to call musical tone. It's got a box with a speaker in it, and it plays a song. And then there's a keypad. The players, or the numbers on the keypad, correspond to a musical note. So the players need to then repeat the same song that they've played there. You can change the difficulty by changing the length of the song. If it's Happy Birthday to You, that's only a few notes. But if it's the full Happy Birthday to You song, that's a lot harder for them to do. You can also change the randomness of the song. And by that, I don't mean just random notes, but children know Happy Birthday to You. It's the most dreary song in the world, but they know it. Some children know the Super Mario Brothers theme. So it's a little bit harder for them because not all of them know that theme song. Very few know the Tetris theme song. So if you choose a song based on how much the players know those songs, it's harder for them to guess what the next buttons are. This, by the way, is super amazing for kids to do because they all gather around and they listen very quietly while the trying to hear what the next note is. It's fantastic because I love when children are quiet. They should be seen, not heard. Parent of the year. Another fun puzzle is one I call Simon Says, which is there's a bunch of boxes and they've each got 2 buttons and 2 lights on. I made 5 of these, and what happens is the lights on the boxes come on in different patterns across all the devices, and the players need to sit and repeat that same pattern across the devices, which means they need to interact with each other, they need to be aware of where they are in the pattern, they need to look at what the other players are doing. It's great. You can change the difficulty by changing the number of devices that are involved in the pattern. So I've got 5 of them that I eventually made. If only 2 of them are involved, it's a lot easier because there's just 2 players interacting with each other. You can also change the length of the pattern that they have to match. Adults seem to struggle with 8. I don't know why. 8 or more, they fall apart. You can also change the number of buttons that are involved. So I don't mean physically removing the buttons, but if only the left light shows up, the players only need to remember the order that they are in with the buttons. This one is also really fun to watch the players do because kids have no chill. And if one of the players gets it wrong, they all lay into that poor child, calm as a bitch. So this is just a handful of some of the puzzles. Once you've solved the puzzles, you need a way of dispensing clues. Obviously, there's the classic, a maglock. Solve a puzzle, maglock opens, something falls out. It's a classic for a reason. You can also do things that maybe stimulate the children's imagination a bit more, such as a treasure chest. Pro tip, make sure you tell them before they enter that they mustn't just force it open because they will strip your servo motors. Another fun one is a sword in a sheath, where if you put a maglock on the side, it produces just enough friction so that they can't pull it out easily until they release the puzzle to get whatever's written on there. And then you can write using the Sharpie, whatever you want on that sword. And then my absolute favorite way of dispensing clues is something I like to call splinters and tetanus. This is a catapult made of wood that I found lying around in my house. My wife describes us as very prototype in nature. She's way too sweet to me because this just looks like shit. But this is really fun because you hide this away so the kids don't see it. And the elastic bands have a lot of tension on there. And there's a servo motor at the bottom that keeps the tension on. Once they solve a puzzle, servo motor releases and it slams forward, makes a loud bang into the wood, and this thing comes flying across a room. You combine this with the musical tone puzzle. So they're all super quiet. And suddenly you get this bang coming through. I like to think that I'm teaching children that it's okay to be scared of chasing your dreams. All of these devices have something in common, and that's how I interact with them. So all of them are running on either ESP8266s or ESP32s. These are great devices. Essentially, they're Arduinos with Wi-Fi, which means that you can turn these into portable web servers, and you can write code that says, when I get an HTTP request on this URL, this is how you respond with it. And then in Arduino land, you've got a loop method, and you just loop and you check, is there another HTTP request I need to respond to? And everything's great. This is fine, except it's single-threaded, which may produce a problem. So on the happy path, what would happen is you'd have a request coming through to the device, and you'd say, hey, has the puzzle been solved? And the device will say, yep, it has, or no, it hasn't, and everything's great. But sometimes it doesn't work out that way. Maybe you're busy calculating the position of the device in 3D space using a digital spirit meter. To do this, some of these devices, these chips that you have, this is an MPU 6050 on the right-hand side, some of them have a digital motion processing chip on them. Some of them don't. You only find out which one you have when you try and actually use it. If you don't have one with the digital motion processing chip on, it could take a long time to calculate the angle in 3D space. So if it's taken a long time and an HTTP request comes in, your device is busy doing something else. Eventually, it works out what the angle is, and it says the angle is now 12 in whatever space you want. But at that stage, that original HTTP request that came in could have timed out. This is a form of temporal coupling. And ideally, what we would have liked to happen is instead of having this happen like this, we would rather have the device sitting there, and it calculates its position in 3D space. And it takes however long it needs to do to get the answer of 12. Once it's worked out the answer, it must then go and see, well, what do I need to do next? Do I need to tell somebody that the puzzle is solved? Do I need to go and recalculate the angle? What is my next step at this point? So I've finished doing this intensive thing. What do I do next? Now, I spend all of my time working in message-driven system space. So in my mind, I immediately reached for MQTT, which is Message Queue Protocol. MQTT works really well for these low-powered devices. because it's lightweight, it's reliable. You can define 3 levels of quality of service for MQTT. It's standards-based, which means if I'm using an instance of MQTT, I can swap that out for another instance later on if I want to move to the cloud, for instance, or something like that. It does have a few drawbacks, though, because it's not actually a queue, even though it's got queue in the name. The queue there says queue, message queue, transit telemetry, but it's not a queue. You can only either have 0 or 1 messages in a queue. I don't know if you've ever been in a queue, but that's not a queue. It's also got a slightly smaller feature set to what I'm used to when it comes to message brokers. But later on, we'll see how we can work around some of these restrictions. So I had all these devices and they were talking through MQTT. The instance I chose was Mosquito because I could run that on a Raspberry Pi, which let me then have my entire setup be portable. And these devices would communicate with each other via messaging. And that's all the context. Now we're going to get into the software development side. So there's 4 things we're going to cover today around software development. We're going to look at how I monitor these devices and what that taught me about monitoring systems. We're then going to look at aggregate routes, as well as how to manage the flow of the escape room, and then working around the limitations of this low-power technology that we've got. So with these devices, the first thing that I wanted to know is I wanted to know when they were failing. So I needed to monitor failures with these devices. When these devices start up, you can go and interrogate, are you starting up because you failed for some reason, or are you starting up because you lost power? If it lost power, the chances are you've just turned it on. But if there's a failure, you need to go and check, well, what was that failure? Maybe you told the device to open a maglock and it failed while it was doing that. It's going to restart and you need to either retry that operation or try something else. Then I want to know if these devices are up. So I started adding health check APIs, /API/health check, and just return a 200. And then I thought, okay, this is fine. What I also want to do is maybe I can look at the queue length of MQTT, because if the queue length is 1 all the time, it means that something's not taking messages off the queue. And I was going down this path and it felt weird. It felt kind of reminiscent of the way that we used to monitor systems in the mid-2000s. Is anyone here old enough to remember those days? There's at least a few of you. So when you had systems in the mid-2000s, it was a lot easier to monitor these things because you had a web server and a database server, maybe an application server somewhere along the line as well. And to monitor this, you had to ask a few questions. Is my web server up? Is my database server up? And can my web server talk to the database server? If those 3 questions were yes, great, your system's working. But we've moved on a lot since then. And something that I spend a lot of time doing is think about how to monitor distributed systems, because it's not just as easy as this. And when you monitor distributed systems, you get a lot of data presented at you. And data isn't information. So how do you take that data and convert that into meaningful information? Now, when it comes to monitoring distributed systems, there's 3 attributes you need to consider. The first is the monitoring area. So what area of your system are you monitoring? And by that, I mean, are you monitoring the infrastructure of your system? Are you monitoring the applications of your system? Or are you monitoring the actual capabilities that your applications expose? Some examples of questions you might ask that align in different areas is, if you ask, are my devices online? That's monitoring the infrastructure. That's looking at the physical devices. If you're asking the question, are devices responding to message publishers? That's looking at the application layer. Whereas if you're asking, can players solve the puzzles? That is looking at the capabilities that your escape room provides. So that's the monitoring area. The next attribute to take a look at is the monitoring concern. So you could look at the health of your system. Now, there's a many-to-many relationship between the monitoring area and the monitoring concern. So you could look at the health of your infrastructure, the health of your application, and the health of the capabilities. You can also look at the performance of your infrastructure, application, capabilities, and the capacity of your infrastructure, application, and capabilities. And then how you interact with these monitoring systems is the third attribute, which is the interaction type. So is it passive? Do you go and look at a dashboard every now and then? Or do you go and look at some log files? Or do you look at your OpenTel traces? Is it reactive? So if your system notices that something is happening, does it do push notifications to you so that you can look and say, oh, we need to do this? Or is it proactive? Does it automatically try and compensate for the changes that's happening in the system? Now, with these attributes in mind, what was I monitoring when I looked at health check APIs? With health check APIs, I was looking at the health of the infrastructure reactively. Okay, great. That's a good start. What about the MQTT queue length? When I was looking at that, that was looking at the health of my infrastructure passively. Wait a minute, that looks familiar. I was getting the same level of information out of here. And in fact, the health check APIs would give me false positives because the health check APIs would return 200, okay, everything's great. But the C++ library I was using for MQTT wasn't picking up messages. Something had gone wrong in the library. So the health check API was saying everything was great, but the application wasn't actually processing messages. In this case, the duplicate information meant that I was getting no benefit from the health check APIs. So using those attributes to look at what information I'm getting out, I can start taking a look at which elements of this data is noise and which actually gives me something meaningful. Looking at the failures, if there was a failure, it would push a notification to my phone. So there was reactive monitoring of the health of my infrastructure again. Maybe not terribly helpful. If I had canary devices, so if the players were solving the room and I had a set of backup devices next to them and I was solving one puzzle ahead of them, that would be proactive monitoring of the health of my capabilities within the system. So these different attributes allow you to inspect what you're monitoring, what information you're getting from that. If you apply that to some more real-world systems, let's take a look at queue length. If we're using RabbitMQ or SQS or something like that, and you look at the queue length as a metric that you monitor, that's passive monitoring of the performance of your infrastructure, which may be helpful. But is a queue length of 5,000 good or is it bad? It depends on how long it takes to process those messages, right? So maybe we look at the processing time of those messages. That would be looking at the performance of your application because it tells you how long it takes to actually process a message. Is that enough? Well, maybe we could look at something else. So we've got a metric called critical time of systems. Critical time tells you when I send this message up until when it's finished processing, how long has that entire duration taken? So that includes queue time, processing time, network transition time, everything. That gives you information about the capacity of your application, which is potentially meaningful. If you had a system where you auto-scaled based on queue length, that would be proactive monitoring of the performance of your infrastructure. But remember, queue length on its own is maybe not sufficient. So using these different attributes, you can interrogate, well, what am I monitoring and how am I reacting to this monitoring information that I'm getting? And is it meaningful? Because if you're monitoring large-scale distributed systems, there's a lot of noise. You need to get some insights out of that rather than just accept the noise. Let's take a look at aggregate roots. So the musical tone puzzle was one of the earlier ones I did. And this was great because it's a nice self-contained puzzle, which means that all of the logic is self-contained within the box itself. I could completely change how the puzzle worked and it didn't interfere with anything else in the escape room. The only requirements were it had to publish a message when the puzzle was solved, and it had to subscribe to messages telling it to change the difficulty. With this in mind, this was a good service boundary for this device. If I was reading the Blue Book, the DDD Blue Book, this was a good example of a well-defined aggregate root. And then I thought, okay, well, this is great because that means that all of my physical devices are now good ideas of boundaries. But it's not. So when I had the Simon Says puzzle, we've got these distributed devices and they have to communicate and work together. If I had another process running that would go and publish a message and say, hey, the difficulty is now 5. It goes to MQTT and my devices go, okay, what does 5 mean? Who's going to change something? What needs to happen? In this case, the aggregate root isn't around a physical device. Logically, the aggregate root needs to include all 3 of these devices. So the boundary is distributed, but logically it's one aggregate root. What I ended up doing was I had the devices, when they come online, they have an election and they decide, okay, this one is now the primary, the other 2 devices become secondary. They set up a peer-to-peer network between them using TCP, not MQTT, and then the primary device would go and subscribe to MQTT, which means when the controller sends a message to say the difficulty must change, it only goes to the primary device, and the primary device then says, okay, everyone, difficulty is now 5, which means the pattern is me, you, him, you, she, me, you. The primary is the one that decides all of that. If something goes wrong with the primary device and it goes down, or one of the other child devices, another election is had. We choose a new primary. That primary sets up a peer-to-peer between the remaining devices, connects to MQTT, and then that one essentially becomes the primary. With the service boundary being all three of these devices, it means that including that, I get a well-defined aggregate root around the devices, but not one on its own individually. If you've got all three of them, you then still have the logic being self-contained, even if it's in a distributed nature. The logic within the service boundary can change without impacting the rest of the escape room. So if the primary decides the difficulty process is now different to the rest of or what it was at the start of the escape room, it doesn't impact anything else. The primary has to publish when the puzzle is solved, and the primary needs to subscribe to difficulty change events. If you have a distributed boundary like this, it's okay as long as logically the service boundary includes all of these things and they are treated logically from the rest of the system as one. Some examples from more real-world systems that I've worked on. If you've got a stock service and a user is trying to delete an item from the stock service or delist it, and the stock service goes to the user authentication service and says, does the user have permissions to delete this item? And the user service says, yes, they do. This is not an encapsulated service boundary because the stock service doesn't have enough information to make the decision about whether or not a user can delete the item. It needs to go outside of its service boundary to ask, well, can the user perform this operation? In this case, the service boundaries are poorly defined if that was the aim of your design. It doesn't necessarily mean it's bad, but if you wanted encapsulated service boundaries, this does not meet that requirement. Another example might be a claim service if we're working in the insurance space. I'm pretty sure a few of you are working in insurance. If you've got a claim service and the claim service needs to check, has the user paid all of their premiums? That's going outside of the claim service. It has to go to the payment service to say, well, are the payments made up to date? Another example, maybe you've got an order service. You're doing an e-commerce site, and the order service says, customers place this order for 50 items. Hey, stock service, do we have these 50 items? These are all examples where the boundary doesn't have enough information to make the correct decision around whether or not it must continue with the operation. Now, you might think, well, okay, a good way to fix this is if the order service needs to know anything about the stock, why don't we just make the boundary of the order service bigger and we include the stock service in the order service? And sometimes that is the answer. But something I learned with this adventure is that sometimes you can go the opposite. So you can make the service boundaries smaller. For instance, if a user is trying to remove stock, if the aggregate root was around a stock removal service, the fact that the user can send a message to the queue on that broker or the topic on that broker, and they've got the permissions to do so, means they have permissions to remove the item. You don't have to go and check that, which means the fact that you can use it means you've got access. You don't need to ask that question. You essentially are checking whether or not the person can perform the operation if you have an aggregate root per operation rather than an aggregate root per thing. Things are nice because you can reason about them. You can reason about products or customers. You can touch a product. You can pick it up. You can also touch customers and pick them up. Don't though. But people don't interact with your system via things. They interact by doing things, by verbs. And if you have verbs as your aggregate roots, it means that the verb only needs to know or contains what it needs to be able to make the questions or answer the questions about whether or not it can continue on. What if the business rule was they can delete items from the stock service up until a value of 5,000 Rand? If it's more, they need to get approval. This still works because if they've got access to remove an item, that they send a message and the stock removal service says, oh, this value is more than 5,000. I'm going to send a message to the approved stock removal service. This is a separate aggregate root that takes place. And that aggregate root has got, right, now only the people that can approve have got access to send messages to this to approve it. Again, those boundaries are self-contained. The key thing here is that service boundaries are your business rules. And if you embrace those business rules and reflect them in your aggregate roots, you can make a lot of cross-service boundary communication irrelevant. You might ask yourself, well, if the service boundaries are small, doesn't that limit you in terms of the complexity of the system you can build? And that's a great question. And we're going to get to that when we talk about message flow. Now, the escape room has got a bunch of these devices and they communicate with each other via sending messages and receiving messages. When I started building these puzzles, it was fine because I had a puzzle and I had a clue dispenser. All I needed to know was, do I need to make the puzzle harder or more difficult? Harder or easier, sorry, that's the same thing. So the devices could measure how long time has passed since they've been on. And they could track, well, okay, it's been 30 minutes. They should have solved me by now, so I'm going to decrease my difficulty. And this was a good start until I added more puzzles. Because now this puzzle and the first puzzle come online and they're both tracking their time. And they're like, well, okay, now it's taken 30 minutes. Hey, has the previous one been solved? And now the new puzzle needs to ask the previous puzzle, have you been solved? Previous puzzle says yes. And then the new puzzle can adjust its difficulty based on that. And then as you start adding more and more puzzles, this becomes unworkable. You've essentially got just this mesh of communication trying to find out what the state is of the escape room at any one point in time. And it didn't quite work out all that well. So what I ended up doing was I came up with the concept of an escape room run, which was a virtual device that I added into my escape room. And the escape room run did a few things. Essentially, it was a state machine. So it had a start state and a completed state. When players started the room, they were on schedule. They were on track to complete within the 50 to 60-minute window. And they would solve puzzles, and time would pass, and more time would eventually pass without them solving puzzles, and they might end up behind schedule. This is a state transition. So we've gone from the state of being on schedule to being behind schedule. At that state transition, we can then go and generate messages to say, okay, everyone, decrease the difficulty of all the puzzles from here on out. All the puzzles receive that message and they then go, okay, I need to make myself a little bit easier for when the players eventually get to me. The players then solve some puzzles, they solve some more puzzles, and they get back on schedule. At this stage, we've had another state transition change. We can go and send another message to say, increase the difficulty just a little bit here, or we could leave it. And eventually, the players could be ahead of schedule. They could be going too quickly through the escape room. So we could transition to a new state. And at this state, we would again send another message to say, make the puzzles more difficult. So the escape room run is tracking all of this. And time passes, they solve puzzles, and eventually they get back on schedule. And at any of these three states, they can complete the escape room, either ahead of schedule, on schedule, or behind schedule. Ideally, they would finish on schedule, but it doesn't always work out that way. But the escape room run is a virtual device that was a state machine, and it did a few things that were very powerful. The first thing it did was it tracked the entire time of the escape room. It was the only thing that was keeping track of how long it was taking. It adjusted the difficulty based on how long it was taking to do each bit of the escape room. Importantly, though, it could completely change the flow of the escape room. So if the players were going really, really slowly, the state machine could decide, okay, those two puzzles are no longer part of the escape room at all. They're not going to form part of anything. As soon as this puzzle is solved, all three of these clue dispensers are going to open up. So the state machine could change the entire flow of the escape room if it needed to on the fly. But the best part was that the puzzles didn't need to know anything about this. They just had to respond to difficulty changes, which meant that I could do really complex flows and have all of that complex logic tested on its own while still having just the devices focus on what button are they pushing over here. The state machine is essentially like an orchestral conductor. It's controlling all of the instruments in the orchestra. We've got the violin players and it's saying a little bit more over there. The percussion must come down a little bit. Change the tempo, keep things up. While in most orchestras, the conductor probably could play a violin, they're not playing the violin. The violin player is busy following their algorithm, or as they like to call it, sheet music. And all they need to do is then respond to what the conductor is saying about louder, softer, faster, slower. They're just responding to slight tweaks, and the conductor is responsible for making sure the entire musical orchestra produces a harmony, a symphony, something that sounds good for the audience. And my escape room run was doing the same for the players in my room. Essentially, it was a implementation of the process manager pattern. In .NET, we call this sagas. It's not sagas, so don't do that. But it's an implementation of the process manager pattern. Other ways I could have done this is I could have used the actor model. This is especially good because there are discrete state transitions that were taking place. So actor model would have been a good fit. The routing slip pattern would have been another good opportunity. This is an implementation of orchestration. So there's a distinction between orchestration and process management. Now, the benefits of this is that the aggregate routes, the devices, they still remain simple because the puzzles don't need to know that the whole room is changing. They only need to know what they need to know. They're like the violin player. They only need to follow their music. They don't know that the rest of the song has changed. But combining this with the devices allows you to build some really complex workflows within your systems. And the complexity, like I said, is encapsulated within the process manager pattern. And you can unit test that independent of having the devices online or working at all. Some examples in real world, you might have a claims capture service. And a claims capture service says, well, a user has submitted a request for a claim. And you go, great, the process has been started. We send a message both to the process manager as well as to an assessor service that's going to go and find a claims assessor or an adjuster, and they're going to go and assess if the claim is valid. And the message can go wherever it needs to go. Once the process manager receives the message to say, hey, a new claim has been started, it can hold on to that and say, great, I've now got an entry to record the status, the overall flow that represents this claim. The assessor service can go and review the claim and say, okay, a claim has been negligent driving, or yes, it's valid. They publish their result. It goes to all sorts of places, but one of the places the result goes to is our process manager. And the process manager now says, okay, so I've got the claim and I've got the assessor status. Great. Now I need to know something about the payment information. The payment service would have published another event earlier on to say payments or premiums have all been paid or something like that. All of the complexity of combining these distinct aggregate routes is contained within the process manager pattern. And the process manager can use that to build up a distributed state of the entire work of our system and eventually say, yes, the claim has been approved or rejected, and start another process after that. Which meant that with my escape room like this, I had all these devices and I had an escape room run that was controlling the flow of all of these devices. Now, I did say there were some limitations to MQTT, specifically there. The limitations that were particularly difficult or problematic for me was that MQTT has no support for delayed delivery. Delayed delivery is where you send a message, but it must only be sent in 5 minutes time, which, as you can imagine, in an escape room where you've got time-based triggers is pretty powerful. It also doesn't have support for time to be received, so it doesn't automatically discard messages that have expired. Surprisingly, it's not a queue. Again, this was a bit of a lie. And it's kind of hard to monitor MQTT, which is also weird. Now, ideally, what I wanted my devices to talk MQTT because it was really powerful for them, because it was such a lightweight protocol. But I wanted my escape room run to talk a more fully fledged broker, something like RabbitMQ, because I could also run that on my Raspberry Pi. And RabbitMQ has support for delayed delivery, time to be received. I can do a lot of complex flows and logic within RabbitMQ. But how do I get these two to talk to each other? So to do that, I implemented something known as the bridge pattern, which comes from Gregor Hoppe's Patterns of Enterprise Integration Patterns book. It's basically the gospel Bible for distributed systems. And the bridge pattern is super powerful because what it says is, well, we've got these systems over here and they're talking this technology. We've got these systems over here and they're talking this technology. How do we get them to communicate transparently in a way that later on you can add additional functionality to either side and still have that functionality flow through? So later on, I could add a service that captures all my Catapult analytics. And the rest of my original system, the MQTT side, doesn't really need to know that there's been any change. The way that it does this is essentially it says, well, we've got these physical devices, these physical bits of code that are going to consume messages. Replace them with logical entities. So replace the sword with the essence of a sword, if you will, or the treasure chest with the essence of that. Do the same for all of the devices. And then on the other side, you do the same as well. Logically, you've just got a concept of something wants messages related to a sword. Then you can do the same for the transport. So you've got transport 1, transport 2, up to transport N. You can have as many of these as you want. When you send a message, the message goes to the bridge, and the bridge says, okay, this is a message that goes to Catapult. Catapult happens to be on MQTT. Oh, it's also on RabbitMQ. So the bridge takes care of making sure that a copy of each of those messages goes to both locations, which means later on you can add a new sword using that talks RabbitMQ. And when your Saga or your process manager sends a message, it goes to both instances of the sword, both on MQTT and RabbitMQ. And while this unlocked the ability for me to use some real brokers in my escape room, more importantly, this is exceptionally good for modernizing legacy systems. I'm sure we've all had to work on horrible technology before, right? So if you've got a system using MSMQ, first of all, my condolences, or worse, ActiveMQ. Second of all, not all hope is lost, because if you implement an instance of the bridge pattern, you can have a new set of technology on the other side, AWS SQS, for instance. And you can add new functionality. You can add new systems on the SQS side. And the bridge will take care of making sure that any messages that need to get to the MSMQ side get taken and sent through there, which also means you can take some of those MSMQ endpoints. You can take one at a time, remove it from MSMQ, rewrite it in Lambda SQS, and the bridge takes care of making sure that any messages that would have gone to the MSMQ instance now go to the SQS queue. It's super powerful for when you're modernizing legacy systems. Highly recommend looking at it, because it means you're not just stuck with either doing an entire rewrite of an old system. You can do rewrites while adding new functionality, while taking bits of old functionality and slowly migrating them over at a time. It is a super powerful technique. So those are the 4 things that I specifically learned and stood out to me through this process. Now, you might ask yourself, well, how did the escape room go? Mixed reactions, really. So on the construction side, I went through a lot of prototypes of this. Here is me. I'm busy assembling the balance puzzle. This is probably about the 4th or 5th iteration of the design of it, and I was convinced this was going to be the one that was going to be perfect, which is why I'm using a brand new LED strip there, because it was the right one. This was a few seconds before I realized I didn't have the through holes in this model yet, so we had to do that again. The music tone puzzle, I wanted it to be nice and small, but I just couldn't get it to be strong enough, and the players kept pushing the keypad all the way through, which is why it now ends up looking like a cell phone from 1997. It's just missing the aerial. I'm also super clumsy, so I cut myself a lot. Underneath those 2 censored blocks, there's a lot of blood. You'll note there's already a plaster on my hand. Yeah. How I'm allowed near sharp objects, I don't know. When it comes to soldering, I'm really not good at soldering. I'm also really not good at thinking ahead, because these 2 buttons need to go through those 2 holes, except there's a thing. I've already soldered the wire that connects the 2 together. You don't need to be very good at mathematical topology to realize that's not a thing that's going to work. So I had to unsolder them. I soldered holes in buttons on my keyboard accidentally. I melted the cable of the soldering iron using the soldering iron. I burnt myself many, many times doing this. It's a miracle that I still have fingers. But I did this, and I got this thing constructed. And I thought, okay, it's going to be worth it, because I'm going to run this escape room for my kids, and it's going to be fun. They're going to have a great time. They're going to come out, and it's going to be like the gladiators in the Colosseum. They're going to work together and face all these challenges. Or it's going to be, I don't know, the kids on the Goonies, but they're going to come out stronger as friends at the end, and they're going to build a strength of camaraderie. And I didn't get gladiators or the Goonies. I got this. Everything broke all the time, and it's honestly embarrassing, because you bring all their friends together and you say, look, we're going to have a big party, and you can run this escape room, and then nothing works. It took about 4 times for me to get this to work. This is a photo my wife took of me while she was laughing her ass off. On the 3rd attempt, I was absolutely despondent at this point. My dog is very happy that I'm sitting on the ground there with him. And I remember that one of my friend's daughters, she's a tiny little girl, very cute, very sweet. She came up to me afterwards, and she put her hand on my shoulder. And she's so sweet. Like, children are very kind and earnest and loving. And as adults, we seem to lose that. So she puts her hand on my shoulder, and she says to me, looks me in the eyes and goes, maybe you should have tried harder. And the kindness hurt for a long time. But I did try hard, and eventually we got the thing to work. So we've got a few pictures of the kids solving some of the more analog puzzles, because we've seen some of the more physical ones, and the digital ones. And eventually they solved it. It took them about 64 minutes on the first try. I've now since run this many times for lots of different groups, lots of different age groups. I continually add puzzles all the time. I'm busy building a Morse code puzzle at this moment. There was a Scalextrics puzzle. There's so many. This is a fun hobby for me now. I'm having such a great time. My kids love doing it as well. I do it for adults as well. So if anybody wants to run through an escape room, hook me up. We'll do it. But the things that I remember the most from this is that the process of building the escape room and the puzzles was one part. Running the escape room was another part. Deploying the system was great. But it opened many other opportunities, many other things that I didn't experience or didn't expect at first. So on the left-hand side, here's my daughter building a little trap room in my parents' house because she had so much fun with the escape room. She wanted to do something on her own. On the right-hand side is my daughter looking at the sun through a solar telescope because there was a magnifying glass in the escape room. And then that became binoculars. Binoculars became telescopes. And now I have to take her camping on stargazing camps because she's obsessed with it. It's fantastic because I didn't expect them to get these new passionate ideas. So when you go through the rest of the talk, or the rest of the talks today, and when you think about how you apply this in your real life, don't just think about deploying things. There's other impacts that when you deploy your systems may be unlocked later on. And I hope you enjoy them. Thank you.